Identifying polynomial functions. An oil pipeline bursts in the Gulf of Mexico, causing an oil slick in a roughly circular shape. The slick is currently 24 miles in radius, but that radius is increasing by 8 miles each week. We want to write a formula for the area covered by the oil slick by combining two functions. The radius r of the spill depends on the number of weeks w that have passed. This relationship is linear. R of w is equal to 24 plus 8w. We can combine this with the formula for the area of a circle. A of r is equal to pi r squared. Composing these functions gives a formula for the area in terms of weeks. So A of w is equal to A of r of w. So we're going to plug in 24 plus 8w in for the value of r into the function of the area of the circle. So A of w is going to equal pi times 24 plus 8w squared. Now if we multiply this all out, so if we multiply 24 plus 8w squared and then distribute the pi, we end up getting A of w is equal to 576 pi plus 384 pi w plus 64 pi w squared. This formula is an example of a polynomial function. A polynomial function consists of either 0 or the sum of a finite number of non-zero terms, each of which is a product of a number called the coefficient of the term and a variable raised to a non-negative integer power. Polynomial functions. If we let n be a non-negative integer, a polynomial function is a function that can be written in the form f of x is equal to a subscript n x to the n plus a subscript 2 x squared plus a subscript 1 x to the first power plus a subscript 0. This is called the general form of a polynomial function. Each value of a in front of the variable terms is a coefficient and can be any real number, but a subscript n cannot equal 0. Each expression is a term of a polynomial function.